Okay, this is Dr. Morton, and this is class day 25, and we're doing our review of chapters 6 through 10. And the test is going to be on Wednesday, I believe. Here's the syllabus. Let's do that. So we'll scroll down. Today's Saturday, but I'm doing the lecture for Friday, October 21st. And then on the 24th, we'll do one more review. And then on Wednesday, we have the test. So I will do a live in-person review if you want, and we'll start the test after the class, or we'll just skip class on Wednesday and do the test online all day. You'll have about, I think, 90 minutes or maybe even 2 hours to do the test online, and you can start at any time. So if you guys send me an email, let me know whether you want me to do a review. I guess I'll just plan on doing a review in class on Wednesday, and then we'll start the test after that anytime you want the rest of the day. If that doesn't work for anybody, then let me know. So that means the test will be available as about 3 o'clock, 3 p.m., all the way till 11:59. You can start it so long as you start it before 11:59, you'll be okay. All right. And by the way, I was very pleased with everybody's presentation last Wednesday. That was great. Okay, so that's the syllabus. Okay, so now what I'm going to do, I'm gonna go ahead and go through one of the older tests, which will be very similar to the one we're going to take. So let's do it. So first, here's the test. I'm going to start with this. This is problem 1, but I'm going to actually do this on paper. And so the first thing I want you to be able to do is I want you to be able to deal with the prime implicants. Well, I want you to be able to transfer from a truth table to a K-map. So here's a 4-variable truth table, and let's see. Can you see me? I think I have a little thing here. Okay, let's turn this on. Yeah, that's not too bad. Okay, let's see how this is. Yeah, that's pretty good. Okay, so and oh shucks, dropped the thing good. Oh shucks. Let me just pause it and get this fixed. Okay, so now what we're going to do is we're going to work on this, and so here's our 4-variable truth table with our specified values for F. Now remember, where do we get F? We get it from our customer. We get it from God. However you want to think about that, it's given to you. Okay. And so the first thing I want you to do is number these squares. I've done this before. It's really important that you keep this straight. Remember, the first one's 0, and then 1. Then we skip to the bottom row because we flip the 2 bottom rows, and then 4, 5, 6, 7. Then we skip the columns because we have to skip flip the rightmost 2 columns and the bottom 2 rows. And so then that's 8. 9, flip the bottom 2 rows, 10 and 11, and then 12, 13, 14, 15. And of course these rows are numbered, 0 all the way down to 15. So keep that straight. So 1 goes in here, a 0, I'm going to leave the zeros out, 0, 0, 1, 0, 0, 1, 1, 1, that should be 9. Let's just check. That is 9, okay. 10 is a 0, 11 is a 1, 12 is a 1, 13 is a 1, 14 is a 0, 15 is a 0. All right, so what do we have? All right, so we've got this row here, we've got this group of 4 here, and then we've got this one all by itself, and we've got this group of 2. So those are all of the prime implicants that you can have, and of these, they're all essential. These 2 ones are not covered by 2 groups, just by the single row. This one's only covered by the group of 4. This one's only covered by the group of 2. This one's only covered by the group of 1. So we have 2 groups with 4 boxes, the row here, and we'll call that C prime D prime. The group of 4, so that's going to be A because it's these 2 columns, and the top 2 rows C prime. So this is going to be A C prime. This group of 2 is going to be A B prime D. The C term drops. And then finally, this is going to be A prime B C D. Okay? So that's that. And then if we want to plot the zeros, we can do that down here in this little box. And we just take them from the map up here. 1, 2, 3 zeros. Another 0 here. Another 0 there. Another 0 here and here. Another 0, so here and here. And I believe that's it. Let's see, let's count the zeros. 1, 2, 3, 4, 5, 6, 7, 8. Let's count here. 1, 2, 3, 4, 5, 6, 7, 8. So we should have 8. 1, 2, 3, 4, 5, 6, 7, 8. And we do. All right, so now we have this group of 4. We have this group of 2. We have this group of 2. We have this group of 2. And then we also have this group of 2 here. That dotted group of 2 is not essential. All the others are essential. Well, actually, this one's not essential too. So we have 2 non-essentials and 1, 2, 3 essentials. Okay, so the row, we pretend it's 1s, write what it would be if it's 1s. In this case, it would be C, D prime, but we flip that and we get C prime plus D. We write what this would be. This would be A, B, C. So that's going to be A prime plus B prime plus C prime. And then this group of 2 here is going to be A prime, C prime, D. So A plus C plus D prime. And then this dotted group of 2 is going to be, and we should definitely dot this one as well because it's also non-essential. So that's that is going to be A prime, B prime. Looks like A prime, B prime. Sorry. Okay. A plus B plus D prime, and then this one's going to be A plus B plus C prime. So those are our so we have our 2 non-essentials here, our essential, essential, and essential. So our SOP function then, if we go back up here, our SOP function is just going to be F equals C prime D prime plus A C prime plus A B prime D plus A prime B C D. And then this one, and then the POS form, we have 2 choices. So first we have to put in C prime plus D, and then we have to put this group of 2, A prime plus B prime plus C prime, A prime plus B prime plus C prime, and then we have to put in this one, A plus C plus D prime. And then we have either this or this. One of these. So total we have to have 1, 2, 3, and then one of the non-essentials for 4 terms. All right, so that pretty well completes this. Let me put this so you can actually see it. So again, we took the C prime plus D prime for the POS. We took the A prime plus B prime plus C prime. We took the A plus C plus D prime, and then we took one of these 2 non-essentials, each of which have 2 zeros in them. Okay? That should do. All right, now let's look at the MUX problem. So the first thing we want to do is we want to transfer the MUX problem into our truth table. So we're given it in shorthand notation. So it's a 0 for 0, a 1 here, a 1 for 2, a 0 for 3, a 0 for 4, a 1 for 5, a 0 for 6, a 1 for 7, a 0 for 8, a 1 for 9, a 1 for 10, a 0 for 11, and 12, and 13, a 1 for 14, and 15. All right, so then we draw these into groups of 2. We'll just do a little tick out to the side. Pairs of rows, starting with the first pair. Okay, so this is going to be, follows D, so that's D. This follows D prime. This follows D, follows D, follows D, follows D prime, and then this is 0, and that's 1. So we just transfer these over. D, D prime, D, 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 D prime, 0, and 1. We put in ABC here in the correct order, and that is the solution to our problem. Okay, very straightforward. The key is to divide it up into rows. An 8 to 1, you can do any 4 variable problem. 4 to 1, you can do a 4 to 1, you can do any 3 variable problem. All right, and of course in this case we have C's, or C primes, or zeros, or 1s. Remember, there's always 4 possibilities. In this case, it's either D, D prime, 0, or 1. Those are your 4 choices for the inputs. You have to pick one of those. And that depends on what the pair of rows is. If both rows are 0, you pick the 0. Both rows are 1, you pick the 1. If it's 0, 1, you pick D. If it's 1, 0, you pick D prime. All right. Okay, here we have a flip-flop. And yeah, that's good. So first off, what type of flip-flop is it? Well, so it is a JK. Okay? Because it has a J and a K input. It has a bubble and an edge indicator, so it's a falling edge clock. Does it have a asynchronous set? Yes, it does. And is it active high? So it does have one. Is it active high or low? No bubble, so it's active high. And we call that our asynchronous input because it's generally, these are set up to be asynchronous, not controlled by the clock. All right? That's all for that. Remember, in this one, you can just divide it up into 2 OR gates, each with 2 inputs, going into 1 output OR gate that also has only 2 inputs. So if this is A, B, C, D, you do A, B here and C, D there, and that's fine. That gives you your F. If you do it here, you have to put inverters. You have to put inverters between the layers because of this output bubble. So you have 2 NOR gates, bubble.
Amy Morton Lamb.
Hey, baby.
Hey, how are you feeling about maybe pinball in a little bit?
Yeah, that's fine. Do you still want me to take Larky, or do you want to take Larky?
Do you want to? I was thinking maybe we could like meet you at pinball, and then you could take Lark from pinball to ballet.
Okay. So do you want to go to pinball now?
Well, or like Stop. Don't yell at me.
Okay, sorry. That was my daughter. A little interruption there. Coordinating. I'm taking the grandbabies to pinball. All right. Okay, so anyway, so we do if A, B, C, D, then we do A, B, C, D, or you can mix these up, of course. And now we need either an inverter, and of course you can use a NOR gate with an inverter as an inverter by tying the inputs together. And then these would go into a single output NOR gate, and that's F. So remember, you have to have these inverters, both for NANDs and NORs, but not if they're just standard ORs and ANDs, you don't need it. But if they're NANDs and NORs, you do need the inverter. All right. So minimum circuit here. This is fairly straightforward. So what does this look like? Well, so you have a group of 4 here, you have a group of 4 here, and you have a group of 4 there, and that's a consensus or a non-essential PI, prime implicant. These, of course, are both essential. So your minimum solution is going to have these. Well, what's this one going to be? That's just going to be A prime C prime, and this one is just going to be AB. Okay, so your circuit is just going to be 2 AND gates with an output OR gate if it's in SOP form, A prime C prime and AB. But because the A changes from a prime to a non-prime, and if there's a delay through that inverter, then you could find yourself with a hazard where you would get F would drop. If F were supposed to stay at 1, it could actually drop to 0 and then come back up depending on the timings. And the way to fix that would be to add this one consensus term, which of course would be B C prime. And the reason that works is because there's no A in that term. So the change in A wouldn't affect that term, and it would still stay as a 1. Okay, now we have this this VHDL code, and so we have A ANDed with B ANDed with C after 10. Now again, you guys are really doing Verilog. So the Verilog code would look like this. It would be E equals A ampersand B ampersand C, and we'd put the pound here, we'd put this pound 10 here, or yeah, pound 10 or whatever. And then F would be A bar Y. Actually, the pound 10 should go here. And then H would equal E bar F. So it's very similar. We just don't use the keywords AND or. We use the same symbols that we would use in C, the ampersand and the vertical bar for bitwise. And on single variables, you can also use the double ampersand or the double bar, which are the logical. But for single bits, logical and bitwise have the identical result. Not for vectors, but just for single bits. All right. So here we have an expression, and we want to plot it on here, and then read out the in this case the zeros. Okay, so these are min terms. So well, this one is a min term. A, B prime, C, D prime. So A are these two columns. B prime would be this outside column. C, the bottom two, and D prime the bottom. So the one goes there. D, C prime. So D, the middle 2 rows. C prime, the top 2 rows. So it's this row. This is DC prime, or C prime D, better. And then A prime, first 2 columns. C prime, top 2 rows, so it would be these 4 boxes here. And then D, it would be these 2 boxes here. So this actually is just a subset of the DC prime. And as you can see, we have a DC prime here, so this really, we could have dropped this term. And then AB. A, first 2 rows. B, this row. So AB is this row. Now we read the zeros out. So we have 0, not 1, 2, 3, 4, not 5, 6, 7, not 8. Or I'm sorry, we do have 8, not 9, not 10. We do have 11. And then we do have, and then we don't have 12, 13, 14, or 15. So that's the end of it. 0, 2, 3, 4, 6, 7, 8, 11. 0, 2, 0, 2, 3, 4, 5, 6. Sorry. well, anyway, 0, then the 1, not the 1, 2, 3, 4, not 5, 6, 7, 8, not 9, not 10, 11, not 12, 13, 14, or 15. All right, note this is asking for the max terms, not the min terms. So we want to read off the zeros, not the ones. Starting with the POS form, how do we switch this? This is pretty simple. We just do the double inversion and partially expand it. When we do the double inversion, then we get A prime plus C plus D prime primed plus B prime plus D plus C prime prime quantity prime. So this is our big output NOR gate, and these are individual NOR gates because of these little primes here. We didn't change anything in here because we never actually took the primes inside. All right, now this is the last problem where we're going to look at this. So we have a D flip-flop. We have 10 nanosecond propagation delays after the set or the clock edge. We read the D at the clock edge. We're not going to worry about setup and hold times for D. We know that Q is 0 at the beginning, so we'll mark that. And we have what? We have active. Well, we have a fault. We have a rising edge clock, and an active high set, active high. So let's color in all the places where the set is active. It's going to be where it's high. Make sure you pay attention in case it's an active low set, in which case we color in the parts in between. But in this case it is active high because there's no bubble. There's no bubble on the clock, so it's a rising edge clock. Now we know these edges, so this edge takes effect, so we'll go ahead and bring this down here. This edge is blocked. This edge takes effect. This edge takes effect. This edge also takes effect. Sorry, can't draw very well. This edge is blocked. This edge is blocked. Okay? And then here the D is 0. Here the D is 1. Here the D is 0. Here the D is 1. And that's it. And then these edges are asserted here. So the places where we can actually have a change, we can have a change here. 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 We can have a change here and here. So these are tricky because so we go to here. Now this first one's a 0, so nothing happens. This is a set, so we're going to go up. We're going to stay set till at least here, but it's still a 1, so we're going to stay set till here. Now it's a 0, so it comes down. We're going to stay set to at least here, and it was a 1. It goes up, but then this was asserted, so it stays up here and stays up until we don't have anything to indicate when it goes down. So this is our final. Now notice it could have changed here, but the set keeps it set. If that were clear, then it would have gone down, but it's not, and it just continues on. All right, so that's it. You don't have to have this vertical bar here. All right. So that pretty much completes that. Make sure you can see it all. Okay. Yeah. And you can see it is a rising edge clock, and there's an active set, active high set. Okay. That's pretty much that test. All right. Okay, so I will cover some more stuff on Monday. And on Monday, I'll try and make sure there's nothing that's asked on the test that I've missed so far. I haven't actually finalized the test, so If I add anything weird I haven't covered, I'll make sure I include it. And with that, I think that this should be a good, hopefully a good review for this test. We'll do another one. We'll do a different one on Monday. All right, we'll see you Monday.